Hello students, let's look at the starters that we had the other day and why this GDP data was a little bit problematic to make a model of. Remember that the first data here that we have, it's actually quite regular. It's actually a perfect exponential relationship, because every time we go further here on the y variable, we always multiply it by 6 every time, so there is a constant growth factor. And in this data, the next one that we have, we don't actually have the same growth factor. And moreover, the year here, we actually have found out a way. We define a new variable that says the number of years from 1990, so it helps us making it simpler. So we have now value from 0 to after 2 years, 4 after 4 years, and so on and so on. However, now it's still a little bit problematic, because the thing is, if you look at the previous one, the previous data here on top, if you look at the x value, it grows, or it goes further by 1 unit every time. So 1, 2, 3, 4, 5, and so on. So that's why when we try to find a formula, it was quite simple. It's just taking the first one, the first value 0.2 times 6 to the power of x minus 1 or something. However, here, even though if you find one growth factor from 1990 to 1992 to be, let's say, 1.026 that we have calculated actually, this was a growth factor over 2-year interval. You see, remember, this is actually from 0 to 2 from on my x variable. So basically, you have gone into 2 steps. So you have actually gone into the first year and then the second year, which is not really shown here because this is taking 2 yearly steps in one go. So what does it matter? How can I now adjust this into my formula and find the right growth factor? So we can do this easily actually, thinking about, okay, my beginning original basic formula is y equals a times b, which is the growth factor, power x. And a is always the beginning number, very easily. It comes from actually substituting 0,6707.9 into this form. And because I will have b power 0, and b power 0 is just 1, basically I will end up with the y value 6707.9 equals a. So a actually take the value of the first y value 6707. So basically I will have y equals 6707.9 and then still times p power x. And now I still need to find the value of p here. And remember, algebraically substitution always works. So we could, so I'm going to delete this one here. We don't really need it. We don't want it anymore because we would like to actually do it differently now. So, okay, let's just take it out. And I'm going to just pick, let's say, one value. So let's say the next one doesn't have to be. You can also pick 1996 for instance. But let's say for the sake of simplicity, I'll just take 2,6880. If I substitute those values here to my current formula, I will have 6,880 and then equals, later on I'm going to write it down, but my x value I substituted will be like, I'm substituting will be 2. So now I'm going to write down the rest of the formula, 6707.9 and then times b. So in this case, now we can solve this algebraically to find b. here we have actually b squared, so later on we have to actually square root it. So let's see first, removing this times 6,000 something, we are going to divide both sides by that number. So in the end you will have 6,880 divided by 6707.9, and then that will be equal to b squared, and because we need only b, we are going to square root both sides. So in the end what you have is square root of this number over here. Okay, so just grab your calculator and take the square root of this number, and that will be your b value. So if I do so in my calculator very quickly, you can try that as well. It's probably not going to be shown here, but you can try it in your own calculator, and if you do so, then you will get a value which is approximately 1.0127, and so on and so on. So maybe if you round it to 3 decimal places, that will be 1.013. Okay, so of course this is not the only way. We could also maybe think, oh, let's say if I do not want to take this value, the second one, the second point, I can also do it differently. So what I can try now is maybe I'm going to take the fourth value here, so 4,7347.7. So in that case, what I could do is, what I'm substituting now will be something different. So in that case, I am going to have to enter for my y value 7,813.2 here, and x value is 6. However, the rest of the process is actually just the same. So algebraically, we remove this times 6,000 something. So we are going to just divide this value on the left hand side by that number. And this will be equal to b power 6. So now the only thing you have to do is, instead of square rooting, because it was power 2 before, now you're going to take the 6th root of the left hand side. So basically you're going to take the 6th root of 7,813.2 divided by 6,707.9, and just use your calculator to do so, and that will be the b value that you have. So hopefully it helps you now to understand why we need to do this step instead of just taking one growth factor value from the second data divided by the first data. Okay, try that and good luck.